What you see here is the time and the progress in the project. In the ideal case, we have this black line here. This would be the ideal progress of a project, but we usually have delays. And one root cause of the delays is shown here. By handing over data from one phase to the next phase, we have to retype or somehow to grab the data out of the tool into the next one. This just eats time. And the next effect is that we lose data that has already been developed and engineered, and we have to redevelop and re-engineer them, and the effect on the overall progress is quite amazing. And if you go over the fairs and you talk to the providers of engineering tools, they all will promise you the sunshine. Yes, our tool is so open. You can export and import everything. Here we have a wonderful Excel interface. Yeah. If you then look a little bit deeper into this, it is sometimes painful. And so we ask ourselves in a scientific way, can we find the key criteria, what a tool should bring with it to be open, to participate? And these criteria I want to present you now. They are the result of university cooperation on the first hand with the Helmut Schmidt University in Hamburg, and later on with our colleagues from Vienna, sitting here, from which was Professor Iffel. If you are a tool user, then I would like to give you questions you can ask to your vendor. If you are a tool vendor, then think about some of these features. We believe that some of the features I'm going to present now are not even on the table of some product managers because they are not aware that this could be of importance. Because many of these features you don't need within the tools. They only get value if you look over the plate. So there are some obvious things, of course. If you want to be an open engineering tool, you need to provide export functionality. That is trivial, that is simple. A good way is to provide a proprietary file format. This is in many cases already sufficient. But of course it is better to have an open file format, because an open file format has somehow a standardized syntax, possibly a standardized semantics, while proprietary file formats may change from version to version, or even from subversion to subversion. Even better would be a software API. This would be the most generic approach to get data out of engineering tool. Second, and here we come already to some weak points in typical engineering tools. What we need is identifiers for each object. And if you go over the fairs, you often see that they assume the name of an object as the identifier. This is not a good identifier. Names can change. And if you look over the life cycle of an object, the name will probably not be identical over the different tools. So what we need is at least an ID for each object, and a better way would be a stable ID for each object over the lifetime of the object. Now you see the point. When you have an ID that is an integer, maybe you just count, this is object number 5, 6, 7, 8, and then somebody removes object 5, then this identifier is free. If you then create a new object, then you can give it the 5 again. Within a tool, this is perfectly fine. But in an ecosystem with other tools, this is really corrupting everything. Think about that. Then we need formal functionalities. For instance, we need version information. If you export something, then we need somehow at least the version of the export file of the whole document. Even better would be functionality that gives me the version of every object. What we also need is integrity checks. Please put somehow a checksum of the overall file in the end of the file or somewhere, that we can prove whether this file is still valid or already corrupted due to transfer issues. Next thing is, when you export data, please also provide type information. When you export thousands of signals to me, it's really heavy to make value out of these data. But if you give me the types, digital input type, digital output, analog input, analog output, then you can give me hundreds, thousands, and 10,000s of signals. When I understand these basic types, then I can understand all the instances also. Just putting out raw data without type information is really useless, does not help. So then, with respect to the import functionality, if your tool is open, then it provides the possibility to read a proprietary file format, or better, an open file format, and even better, a software API to import data. That is again trivial, but this is something that most engineering tools do not provide, manipulation functionalities. I need functionality to change data inside of the tool. And I want feedback about the success of that. Example, when I want to import 20 signals, well, how do we do it today? I import an Excel sheet. But I do not get information about the success. In the worst case, I made a mistake in the Excel sheet and the whole database inside of my engineering tool is then corrupt. This would be the worst case. Then the second is that the tool might check the Excel sheet before importing, finds the mistake, does not import, but does not give me a hint where the mistake was, or whether some of the elements has been imported or not. What we need is dedicated feedback about the success of every import operation on object level. That is really helpful. Then, next is, we need the completeness, for instance, of signal data. If you give me a signal, please give me the name, give me the direction, give me the signal type, maybe the IC data type, and the physical address would be helpful. With respect to hardware data, we need the type of the components, we need the hardware address, we need the allocation between signal and hardware. With respect to the project, we need the project name, we need structure information, we need the project status, lots of things. And of course, import-export functionality needs to be documented. If you go over if you look at the landscape of engineering tools, there's lots of functionality hidden and undocumented. If you complain, then the product manager tells you, yeah, we can do all this. We forgot the documentation, but it's there. An undocumented feature is equivalent to not existing feature. All the effort to develop this functionality is then useless. Now you have seen lots of slides, but our metric was a little bit powerful than just writing these slides. What we developed together with the Helmut Schmidt University in Hamburg is this Excel sheet. This Excel sheet is, let's say, summarizes all these different criteria here of different aspects of completeness, documentation, import and export. And here you just enter true or false. We wanted a repeatable evaluation that is somehow stable. You just enter here 1 or 0 for is existing or not, and then you get your judgment. Example here for the first criteria around the export functionality. Here you ask yourself, does my tool has an export for proprietary files? Here you say yes. And does it provide an API? You say no. Does it have an ID? Yes. Is the ID stable? No, unfortunately not. And so on. You answer these questions and finally you get the judgment here. So there is a formula visible in this Excel sheet telling you why you get here 55%. And with this metric, we started to evaluate first 7 engineering tools, and then we came into discussion with Professor Biffel, who is covering all the Austrian engineering tools. So we finally came up with 15 engineering tools under test. And what's interesting is these are the results of the different tool types. Here we have hardware configurator tools, PLC programming tools, electrical planning tools, and tool suites evaluated over the different categories of questions. And what's really interesting is that the hardware configurators are mostly poor in openness. And then the biggest or the highest level of openness we found in tool suites. From nature, this is understandable because tool suites already know that there are different domains where you need data exchange within the tool, so they are already aware that, for instance, an ID could be helpful. This is just an example. By the way, over the interviews and over the time of the university cooperation, we found out that some engineering tool providers already improved their tools with respect to these categories, so that this graphics today, if we would repeat it today, it would probably look a little bit better. But still, we all should be aware that basic functionality is required to export and import data and all via AutomationML. The top 4 openness features we need. An open engineering tool should support export and import of data. It should provide stable identifiers for objects. It should deliver class or type information for every object. And it should provide me feedback about the success of import actions. If we just find these 4 features, then we are already on a very good shape here. You can download this Excel sheet here on this web page, and you can judge your own engineering tools by yourself in order to get an impression about the openness level of your engineering tool. And you can use this Excel sheet as a tool vendor to put these inspirations into the roadmap of your development. That's more or less everything. Thank you very much. If you have questions, then tell me.
Yeah, I have a question. I really like this presentation, and we are also considering other languages for import, export that are directly providing the functions for how is it called? For making updates, for getting the feedback, how the update was finished or not finished. And since I'm not really expert in AutomationML, I would like to ask whether you or anyone else knows about whether AutomationML provides such functionality. That if I do import, that I directly have some standardized mechanism to get feedback and so on.
In general, every question that is related to does AutomationML provide a function, the generic answer is no. AutomationML does not provide any functionality. It is a static data model for modeling data as they come out of the tool. They might be wrong, they might be inconsistent, they might violate every rule, but this violation always comes from the tool. If you talk about functionality, then this is export and import functionality. And here I also have to say we do not have a standardized way on how to provide feedback, how to recognize all those mechanisms. This is probably on the competitive part of the application of AutomationML. And by the way, if you want to standardize things, you always have to look at the boundary between commonality and competitiveness. And the AutomationML itself, here we sit together with Siemens and ABB and all these Marktbegleiter competitors. We can harmonize the syntax and possibly a little bit of the semantics of these data, but the application of the concepts in the tools, let's say the beauty of exporters and imports, the usability and the deepness of the integration is always a proprietary feature in the different engineering tools. And here you can compete with each other. You can provide benefits to the customers.
Okay, thank you.